and we will start at 10. How's everyone doing today?
Good. How you doing?
I'm doing well. Thank you, Joey. And let me share. Okay, and this is the agenda for today. Thank you, Robert. And this is week 5. So welcome to week 5. By the end of this week, we will be 50% into this quarter. Slightly shorter quarter than usual. And they always fly fast. I'm amazed how quickly these quarters fly. It's like one day I'm welcoming everybody, and not too long after that, I'm talking about the final exam, final project, trying to wrap up the quarter. Any questions before we start? All right, so let me show you. I'm going to go ahead and get started. Let me show you the big picture, which you've seen many times before. So we're here. So this week, we're going to cover chapter 6. There's quite a bit of materials. I've developed a bunch of labs, 7 or 8 different packet tracer labs to go over the different parts. And we have 2 days. We have ample time. I'm confident we will get to the end of chapter 6 by the end of this week on Thursday. And then we change directions starting with chapter 7. So if you were to look at the description, cryptography systems, and then implementing VPNs, etc. So we're still talking security. However, we will be changing direction. And we're doing very well from a timeline point of view. So I said this before, I will say it again. We're good on the timeline, and I'm sure we will get to the end of this course by the end of week 9. So let's go ahead and get started. I'm going to go to Google because we will likely need it. And if you have questions, fire away. So the first part of this course is a slide set, and I don't want to spend too much time there. I think Net Academy does a wonderful job, and I hope all of you are going over the material in Net Academy for each chapter that we cover. So maybe 15, 20 minutes, and then we will get to the more interesting part where we can begin to do some labs. But the first 20 or so slides is just me talking, and I will try and minimize that. So let me hit F5 and get started. Endpoint security. Very good. So we're looking at this picture. It's showing an enterprise network, if you like, with a connection to the internet. So we have a router that connects the enterprise to the internet, and we have that line that goes across the router that says perimeter. Another very popular term for that is demarcation point. That is the demarcation point. And this side is you, and the other side, it's your ISP. And then immediately behind the firewall, we have an ASA device. We'll be talking a lot about ASAs, I believe, starting with chapter 8. Adaptive Security Appliance. It's just a security appliance, firewall, IPS, anti-malware, you name it. And then immediately behind the firewall, we have an IPS. And we talked about IPSs before. And the ASA device is quite capable of running an IPS. So the IPS can be a separate appliance, or it can be built into the same appliance as the ASA. And then below the firewall, we have the services that we want to expose to the outside web. Of course, you want people outside to be able to access the web, email, DNS. I will talk about ESA and WSA. And you can think of this as a DMZ, everybody. This is not a bad fit for a DMZ. More likely these days, you're just going to drill a hole through your firewall so people come inside your network to access these services. But it may as well be a DMZ. And then you have the rest of your enterprise behind IPS. And if you remember when we were talking about IPS, I said you want to place it, inline. It's an inline device. and then immediately behind the firewall that connects it to the outside. So 100% of the traffic that is coming into your enterprise will go through the IPS. And ACS is a Cisco AAA, Authenticate, Authorize, Account Service. And Cisco has a lot of different services. Traditional endpoint security, this is most of what we're familiar with today. We have an anti-malware. It started as an antivirus. Now it's an anti-malware that includes viruses, worms, spyware, adware, ransomware, etc. A host-based firewall. So your Windows client has a sophisticated stateless firewall, and host-based IPS. And most of us don't have that. However, there are lots of services out in the market that bundles all of these three different services into a suite. And we talked about semantic endpoint, and I said it's a suite, and it's the most popular suite. And this is exactly what semantic endpoint includes. It's an anti-malware, it's a firewall, it's an IPS. So this is traditional, and semantic endpoint isn't really new. It's been around for a very long time, and other similar products. However, what's really evolving more than anything else is that IPS service. I said anti-malware is legacy, it's stable, we keep it up to date. The same thing is true about firewalls. IPS, this is an area that is seeing a lot of innovation and improvement. Okay. The borderless network, this is a Cisco term, and basically they are saying you can get to whatever service you want inside your enterprise from whatever device you have, a home, PC, a laptop, a smartphone, etc. And it really is borderless, meaning you can get to any service from any device from anywhere. Securing endpoints in the borderless network post-malware attack. We did say malware isn't 100% protection. There is no such thing. Give it up, okay? You can get close to 100%, but there is no 100%. And post-malware attack, where did it come from? What was the threat method and point of entry? What systems were affected? What did the threat do? Can I stop the threat and root cause? How do we recover? Very important. And maybe most important is the very last bullet. How do we prevent it from happening again? Bad things will happen from a security point of view. And the question is, was this something we could have prevented? Is this something we can prevent in the future? Let's say the policy is to update the signature file over the weekend and something bad happened on Thursday. So you have to review the policy and say, is this a good policy? Maybe we should be updating the signature file every night, not only over the weekend. If we had done this, at least we would have been able to prevent this incident from happening. And enterprises, especially sophisticated enterprises, they have specialized people that do this kind of work. And I understand, small companies, they just don't have the money nor the resources to specialize. And they have a few people doing all kinds of different things. But if you were to go to larger size companies, you will find, they have security specialists and they focus on security because it is really a full-time job and a very, very important job. Host-based protection, anti-malware, spam filtering for email, URL filtering for web, blacklisting of IP addresses, of email addresses, of URLs, so to prevent the employees from going there or from data coming into. And data loss prevention, I'm going to assume this is a new term for you. You may want to make note and read a little bit more about it. But in order for DLP to work, the company has to classify the data, which is a huge task. And now the data is classified, we can determine if this data can leave the company or has to stay inside the company. So before we can implement DLP, we have to categorize the data, at least the important data. You don't have to categorize all the data, but in the important data. And then you have to decide, okay, what can leave the company network and what has to stay inside the company. Modern, so what are we adding? So anti-malware protection, okay, we still have that. ESA is secure email, and I will show you a slide that talks about that. WSA is secure web. So basically, we want to secure our email. We want to secure web. And NAC, you may want to write this down. This is network access control. Who is allowed into our network? And we will talk about the profiler and the different products and services that Cisco has for that. But you want to make sure, yep, this is a laptop running Windows 10. Yep, this is Zico, and yeah, he's trying to read his email. Fine, we will give him access. Okay, this is a smartphone. We're not really sure who's logged on, and they're trying to access this database. No, we won't give them access to the network, not to the database, to the network. So we're going to deny them network access. So NAC, network access control. So, and you want to have a profile, and then it makes its decisions based on that profile. What does this say? Yep, encryption is the key, everybody, these days. Encryption is the key. You want to encrypt as much of your data as possible. The more you encrypt, the better off you will be. And many years ago, you know, this is, you know, over 10, 12 years ago, Hewlett-Packard decided that they wanted to encrypt every piece of data on every laptop inside the company. And that was a smart move. It's like, we may lose these laptops, people may leave them behind, someone may break into the car, into a house and steal a laptop, but we don't want them to access the data. Because like I keep saying, hardware is cheap. Okay, the laptop is very, very cheap. The data on the laptop could be extremely expensive, especially if you have sensitive data on that laptop. And what companies want to do, not so much to protect the laptops and the desktops, but they want to protect the data. And the best way to protect the data is to encrypt. That way people can get their hands on the zeros and the ones, but they can't put them in the right order to make sense. All right. Advanced malware protection. I'm gonna go quicker over this, everybody. I think by now we're all comfortable with anti-malware, what they do and how they work. Before, during, after. Okay. Before, you know, you want to make sure you have the latest, the best anti-malware tools and processes. During, you want to detect, you want to block, you want to defend, right? You want to minimize the damage. I think you all know the difference between a virus and a worm. A worm is self-replicating. Worms do serious damage, because if they get inside an enterprise, they can infect every device, you know, within a few hours. And I remember a couple of scenarios where a worm would get in, and they would be running around telling people to disconnect their computers from the network, or trying to go into the telecommunication closets and turn off all the network devices, so the worm wouldn't replicate to more and more computers. And then afterward, you know, you want to remedy, if you can remedy, and you want to learn, and you want to make sure as best as you can that this doesn't happen again. And that's a very, very important point. You know, we got bitten this time. What can we do to decrease the probability this will happen again? AMP, Talos, we talked about Talos. Do you guys remember? You know, we went to the website, Cisco being the 800-pound gorilla. They have services all over planet Earth. They have devices, sensors, if you like, all over planet Earth. They have a team. There's a Talos team. I don't know how many dozens of security specialists. And that's what they do for a living. And whatever they learn in China, they implement in the United States. What they learn in Europe, they implement in China and in the United States. And this is the beauty of having a large scale. You know, this is something large companies can do and smaller competitors can't, because they just don't have the scale to operate worldwide. We saw these acronyms before: AMP, anti-malware for endpoint. This is what you put in your device. AMP for network. So you can actually run an anti-malware on the network, like, you know, where you have your IPS running. It can be IPS anti-malware. So you're checking the files as they come into the enterprise, because that's where you want to stop them. You don't really want to rely exclusively on the endpoint to protect themselves. you can protect the entire enterprise and the network. So these are the two services I talked about before. Okay, Cisco Email Security Appliance and Cisco Web Security Appliance. And I will show you, here you go. This is a good slide that shows you what Cisco Web Security Appliance, it's a service that they sell. And basically they are saying that when a device wants to go out to a website out on the internet, the ASA, security appliance, is going to send a mirror. They're not going to stop the request from going to the outside, but they're going to send a copy to the WSA, and the WSA is going to look at its database and saying, yep, this is kosher, this is not kosher, whatever. However, when the traffic comes back through the WSA. And if it's bad traffic, if it's suspected to be a bad traffic, it will be prevented from going back to the client. So it's a security service that Cisco sells to improve, the web access security. And then, as you can imagine, email is a very similar service for email. Okay. So this is the web controlling physical access. So this is what we're talking about. So people can plug in. It doesn't mean, they have access to the network. You can prevent access to the network. And this is another service that Cisco sells. And here are all the different components. NAC is network access control. So that's what we're talking about. We're talking about layer 2 access, network access control. So we have a server, we have a manager, we have a profiler, and we have a directory service for authentication purposes. And in a nutshell, how it works is you have a profiler that says, okay, who is this device? This is a Windows 10 device. It's in Oregon. Zico is logged on, and Zico is trying to access this service. Yup, this is kosher. We will allow it to happen. Or this is a smartphone. It's in Russia, and they're trying to access some sensitive database, and we will not allow it. We will deny it immediate access, or we can raise a flag and let the operators know, the managers know that, this is a suspicious device. Please take a closer look at it and make a human decision on whether they should have access or not. Clearly, this is an enterprise level service. Small to medium-sized companies may not have the money or the resources to implement something like this, but large enterprises, especially enterprises that are sensitive to security threats, probably would want to do something like this because they can prevent bad things from happening before they actually happen. Any questions on anything I've covered? I know I'm going a little fast, and this is by design. Net Academy does a wonderful job, a better job than I, and I hope all of you will take the time to read all that stuff on Net Academy. Questions? .802.1, I know you all know what 802 is. So let's take a quick look at 802.1x, everybody. 802.1x, okay, is a network authentication protocol that opens ports for network access. So again, we're still talking about network access control. So this is a protocol, that those tools can use to open up the port or close the port. Okay, so this is an 802. And 802 is an open protocol that can be used to leave the port open or close the port if we determine we don't want this computer, this device to have access to the network. And if you haven't seen 802.1x before, I do believe we've covered it in a previous class. You may want to make a note and just read a little bit about it. Just spend 5-10 minutes reading about it, because it is an important protocol and it is one mean of controlling network access. Okay. Yep. So you have guests and you want to give them access. And usually what you want to do with your guest, everyone, is you want to give them access to the internet. You don't really want to give them access to your enterprise network. From current slide, here we are. And this is common and it's standard. And I hope everyone is doing this. Companies will have guests, and you want to give your guest access to the internet, but you don't want to give them access to your internal network. So they can access the wireless access point, and they can go to the internet, check their email, browse, do whatever they want. But we most certainly don't want to give them access to the internal network. I talked about the profiler, everybody. And I said, what is this device? What operating system it's running? Where is it physically? Physically, where is it? Is it on a site, a company site? Is it in the United States? Is it in Europe? Is it in Russia, somewhere else? And who's logged on? And what is it they're trying to do? And then a decision is made based on that information. So this is the first part. 19 minutes, that's not bad. I was thinking 20, 25 minutes, so we're 1 minute ahead. This is part 1 of chapter 6. Any questions about anything we covered? No? All makes sense? Or you will read about it and let me know if you have any questions.
The NAC, is that a separate device or is it a configuration on a switch or a router on the network?
Very good. Thank you for asking, Joey. So it's 2 parts, Joey. So there is the management part, and you're talking about network access control. Very good. So it's 2 parts. First, there's the profiler part, the part that says, what kind of a device is this? Because you need data. Before you determine, am I going to give this device access or not, you need data. So there is the part that collects the data. What kind of a device is this? Physically, where is it? Is it inside an enterprise network? Outside? If it's outside, is it in North America? Is it in Russia? Is it somewhere else? And who's logged on? Is this Zico logged on? Is this the CEO logged on? And what are they trying to do? What services are they trying to access? And then a decision is made, and then it may call 802.1x to shut down the port or leave it open. Make sense? So there is the part that collects the data and makes the decision, and now you want to implement, and you could use 802.1x to actually implement it on the switch level. Does that answer the question, Joey?
Yeah.
Okay. And of course, the profiler and database and collecting all that information is a Cisco service. And Cisco is saying, we can sell you the service. We have the technology, and we can make it happen for your enterprise. And I'm sorry to bring this acronym one more time, CBA, cost benefit analysis. This is not a cheap service, nor is it an easy service to implement. But if security is a top concern, this is a bank, this is a financial institution, et cetera, then you may be willing to pay to have an additional layer of security.
Sigo.
Go ahead, Camping.
What type of interface is it? Is it command line or the?
No, I don't know. To tell you the truth, I've never really seen it, but I would imagine it's not command line. I would imagine it's a GUI.
Okay.
And then, there's an operator, a human being behind that GUI that can use the GUI to make a go or a no-go decision, or open or close decision, to be more precise. But I've never seen that tool in operation. We can Google or YouTube and see if there is a demo. I would imagine there would be a demo, and then we can see what it looks like. Move on. Okay, so this is the more interesting part, and we're gonna do half of this part of chapter 6 today, and we will take our time and we'll do as many labs as we can, and I want to answer as many of your questions as you can, and then we'll save the rest of it for Thursday. Okay. So this is a slide that's basically showing us the ISO-OSI model, and it highlighted data link. And basically it's saying, you know, if you have access to the data link, then you have access to the network. And if we can prevent access to the data link, then we can prevent access to the higher level services. So that's all this is. So I'm going to take my time with this slide. I would like to explain each of these. I would love for you to ask questions. I want to keep it at 1,000-foot level, and then we're going to do labs, I think, pretty much for each of these bubbles. Everybody, so this is the rest of chapter 6. So this is the introduction to part 2 of chapter 6. So CAM table attacks. So who wants to tell me what is a CAM table? One person will do. What is a CAM table? We've been talking about CAM tables for...
And MAC address table for a switch.
Very good. It is the MAC address table, everybody. So we know a switch filters. A switch operates at layer 2. Here we are. So a switch operates at layer 2. And the switch does its job by capturing the source MAC address and which port it's behind. And when the switch has to make a forwarding decision, it looks at the CAM table, this MAC address table. And if it knows, you know, the port for that MAC address, then it only forwards the traffic to this one port. And I'm sure you remember hubs operate at layer 1 and they broadcast everything. And we said that is two problems. Switches have two advantages over hubs. Advantage number 1 is they are faster because they're more efficient. They don't broadcast the data to all the devices on that hub. And number 2, much more important, they are much more secure. And they are much more secure because they're only forwarding the data to this one port where that destination MAC address resides. Make sense, everybody? So you tell me, what would the problem be? Okay, hold on. Let me give you another scenario. So you turn the switch on because we create that table dynamically 99.9% of the time. You can create it statically, but usually it's created dynamically. So when you turn the switch on, the CAM table is empty. And PCA wants to talk to PCB. So it sends a frame to the switch. The switch looks at the CAM table. The CAM table is empty. What does the switch do when it can't find the destination MAC address in its CAM table? Anybody?
Forge packets out every interface besides what it came in through to gather.
Very good. You got it, Joey. And it's called flooding. This is what we call flooding. And flooding basically is I'm going to send it to all, since I don't know where that destination MAC address is, I'm going to send it to all the ports except the incoming ports. And, you know, as soon as I learn about the port, which this MAC address is behind, I will go ahead and add it to my CAM table. So this is what this first bubble is all about. Okay, so what happens when we fill up the CAM table? So the CAM table is a table and you can have so many entries in it, let's say 1,000 or 10,000. So what happens when we fill it up with junk data? And then the switch begins to operate like a hub because it will no longer find the destination MAC address in the table, and it's going to start acting like a hub. And then someone can be sitting on a different port and they will be seeing all the traffic that is flowing through the switch. Does that make sense, everybody? And there are tools out there that you can use to flood a CAM table. And it doesn't take very long because, you know, you're talking a second and the CAM table is flooded with junk data. So this is CAM table attack. So this is what we're talking about here. This is what we want to prevent because it's fairly easy to do. The second one is VLAN attacks. So we all know about trunks that carry data for multiple VLANs. What prevents a bad actor from connecting to a switch and saying, you know, I'm a trunk. And if you leave the switch port configurations at default, you know, the other end of that cable is going to say, fine, if you're a trunk, then I will change a trunk and I will forward my VLAN data to you. And we want to prevent that. DHCP attacks come in two flavors. The very first thing you want to do when you launch a DHCP attack is you want to starve it, because DHCP server is giving IPs from a range. Let's say it's a class C. The entire class C is dedicated for the HCP. So it's from 2 to 254. Everybody, because one is reserved for the router port. So what happens when we starve it and the DHCP has no longer has legitimate IPs to give out, and you starve it by changing the MAC address and making a request. So change the MAC address, spoof the MAC address, make a request, spoof the MAC address, make a request, spoof the MAC address, make a request. You only have to make 250 requests and you've starved it. There is nothing left. And then the second step is to act as a DHCP server, to enable the DHCP server on that network and to start acting like a DHCP server. And instead of giving the legitimate port number for the router, you would give your device as the port number. And now you're forcing all the traffic to go through you. Making sense, everybody? So step number 1, starve. Step number 2, begin to issue DHCP IPs and direct the traffic through you. And this really takes us back to encryption. In fact, a lot of what we talk about takes us back to encryption. And this is why you want to encrypt everything. That way, a bad actor can get their hands on the zeros and the ones, but they're not going to be able to make sense of the zeros and the ones. ARP attack. Who remembers what ARP is? Address Resolution Protocol. Testing your memory this morning. So computer A wants to talk to computer B. The very first thing computer A does is says, is computer B on my subnet or in a different subnet? Do I have to send the frame to the router, or can I directly communicate with this other device? And let's say computer B is on the same network. The next thing we need to know is the MAC address, because at the end of the day, we have to talk to the NIC. So we need to know the MAC address for computer B. And computer A will send out an ARP request saying, if you're the owner of this IP address, give me your MAC address so I can talk to you. Well, what prevents a bad actor from replying to the ARP request and giving their MAC address? Saying, I am PCB. And now computer A will assume it's talking to computer B when in reality it's talking to a bad actor device. Address spoofing, that's easy, everybody. So you can spoof the MAC address, you can spoof the IP address. Basically use a different MAC address from yours, use a different IP address from yours to do some bad activity. And then the very last one is STP attacks. I'm sure you guys remember spanning tree protocol. We covered that in chapter 153. A handful of you are in 153 course, and we talked about this not too long ago. And if you remember, STP is going to determine first, which switch is the root bridge, the root switch, and then all the traffic will flow through the root bridge, the root switch. And what we want to prevent here is a bad actor of forcing their device, to become the root bridge and forcing all the data to go through their device. And this is what an STP attack wants to prevent. So this is an introduction, and I know it's a lot, and I didn't expect all of this to be internalized, but I said at a 1,000-foot level, this is what the focus of part 2 of chapter 6 is. So we're gonna go over each of these independently. But any 1,000-foot level questions here? Is there anything we need to review before we dive into this? If you don't know what a CAM table is, let me know. I will show you one. If you don't know what ARP is, let me know. If you don't know what STP is, let me know. I can show you that stuff before we dive into it. And maybe ask me when we get there. And that way I can do a quick review, and then we can talk about how we can mitigate. All right. CAM table. Okay, this is the MAC address table. And you can create it statically, which means, it will always be there, but nobody does that. Nobody does that because it's an awful lot of work and it changes. So what happens, if you were to create a static a MAC address table, and then 2 weeks later you have a new laptop and you plug it in and it's not going to work because your new laptop has a new MAC address and the new MAC address is not in the table, and you're not going to be able to operate. Now you have to pick up the phone and call IT, and they have to do something. And how many users know, why this new device isn't working on the network? So almost always it's created dynamically, and because it's created dynamically, it can be flooded, and that's what we want to avoid. Okay, so they're showing us, a bad actor can send many requests. All they have to do is change their source MAC address. So change the source MAC address and send something to the switch. Change their source MAC address, send something else, and it's a table. And once the table fills up with junk, the switch is going to start acting like a hub. So what can we do? This is just showing us this is a tool you can download, everybody. Okay, MACOF. And what this tool does is it will flood the switch. You run it and you can see it's changing the source MAC address, and it's going to flood the CAM table. Okay, countermeasures. So what can we do to prevent this? And the answer is port security. And we've talked about port security in a previous class, so I'm quite confident of that. So this is mostly a review. So what does port security do? In a nutshell, port security enables you to limit how many MAC addresses you can have behind a particular port. So you can say, no more than 2, no more than 3 MAC addresses can be behind a port. And that way you just don't have enough flexibility to launch a CAM table attack, right? Everybody, the most you can do is send 3, and that's it. You will be prevented from sending any more requests with a different source MAC address table. And step number 2 is you can decide what do you want to do if someone exceeds that number. Let's say, you set the limit to 3. So what would you like to do if someone exceeds that? You can shut down the interface, okay? Or you can just block more data coming in from a different MAC address. So you can just shut it down. Okay, I'm really concerned something weird is going on here. Or you could say, nope, just accept data for the first 3 MAC addresses and discard the data for the remaining MAC addresses. Because you can stop the device from sending traffic to the switch. So now we're determining at the switch level what to do. We will let it pass or we will discard it. And then there is a timer, everybody. I think it will show you the timer here. And it's saying, how long do you want to cache this data? You can cache it for as long as the switch is running, or you can cache it for so many minutes. And then, after that, because remember, if there is a security threat, it's not going to go on for days. At least that's the thinking. And if you were to cache the data for 2 hours or 3 hours, and you're limiting it for 3 MAC addresses, there's no way they can launch a successful CAM attack. So you turn port security on, and then you determine how many MAC addresses you want to allow behind that port. And then what do you want to happen if they exceed that number? Again, let's just stay with 3 for right now. So we can shut down. So if they exceed 3, shut it down. And then we have protect and restrict. And the only difference between protect and restrict, everybody, okay, is do we log or not log? So protect is not going to log, and restrict is going to log. Are we good with port security? I hope you remember this. I talked about the aging, everybody. How long do you want to cache it? Do you want it to be an absolute clock, meaning it's hour and 20 minutes from when this MAC address showed up, or is it hour and 20 minutes from the last activity? Okay, so that's the difference between absolute and inactivity. So let's do it. So let's do the first lab. And please ask, everybody, please ask. chapter 6. So the very first one is port security 3. And I'm sure by now you've all discovered that 1 and 2, I'm just reminding you to watch these videos on Net Academy. So just go to 6123 and there's a video, and they're usually not very long, 5, 6, 7 minutes. And they're useful. If it's here, you know, it's worth your 5, 6, 7 minutes. So don't skip over it, watch it. So I'm gonna start with lab 3. It's open, and let me do this. Okay, here we are. So you can see I have a switch where I want to implement port security, and I have a hub down below. And the reason, everybody, why I'm using a hub is because I want to have more than one MAC address behind that switch port. Good, everybody? So PC1 has a MAC address, PC2 has a MAC address, PC3 has a MAC address. They will flow through the hub, and I can capture multiple MAC addresses for this port and switch one. Otherwise, if I was to have switch ports with a single computer behind it, I only have a single MAC address behind that. So just to do this lab. So in here, I'm reminding you with the security violation mode, you know, shut down, restrict, protect. This is a great pyramid, everybody. And let me, okay, this is a great pyramid. And I'm going to talk about it for a couple of minutes. And you've seen this before. You may not remember it, but we've covered this in previous courses, and we will be talking about it later in this course as well. So at the bottom of the pyramid, we have port security, which is the lab we're going to do and what we just finished talking about. And this is trying to control how many MAC addresses can use this switch port. Okay, and this is like a foundational layer. And port security enables other LAN security features like DHCP starvation. Do you guys remember when we talked about DHCP attack? I said step number 1, starve the legitimate DHCP server from IPs, so it doesn't have any IPs to give out. And step number 2 is the bad actor device is going to start acting like the legitimate DHCP server. Well, to starve the DHCP server, you have to make many requests with different source MAC address. And if that port is limited to 2 or 3 MAC addresses, then you don't have enough source MAC addresses to starve a DHCP server. So it will help that. ARP poisoning is when PC1 wants to talk to PC2 and they're in the same network, and PC1 sends out an ARP request, and usually PC2 would reply with its MAC address. Well, what's going to prevent a bad actor device of replying with its own MAC address? Good, everybody? And it replies to many ARP requests with its MAC address. And if we are to enable port security, then we can limit the amount of damage that bad actor device can do. They can only, you know, use 2 MAC addresses, 3 MAC addresses, but they're not going to be able to reply to every ARP request with their MAC address and saying, come and talk to me, come and talk to me. Make sense? Okay. So we talked about DHCP. DAI is dynamic ARP inspection, and IPSG, this is IP source guard. This is making sure that devices are not spoofing their IP address, devices are not spoofing their MAC address. So this is the pyramid we're gonna climb together today and on Thursday. And we're starting with port security and then moving on to DHCP. And the top 2 layers, DAI, dynamic ARP inspection, and IPSG, IP security guard, require DHCP snooping. So if we don't have DHCP snooping enabled, then they're not going to be able to do their job, but let's wait until we get there. So let's do port security. Okay. Before we do the lab, okay, show Anderson. Okay, let's do it, what they say. So let me come here. Show interface status. Okay, and this is basically just to show you the default. And the default is saying that the port is enabled. Nothing is plugged in, nothing is connected, but it's enabled. And if somebody was to plug an Ethernet cable in, it's gonna work because this is how the switch is configured by default. And one more thing, show interface gig 01 switch. Okay, and let's take a look at this, everybody. And what this is saying is the switch port is enabled. The administrative mode is dynamic auto. I hope you remember this from a previous class, which basically means if a neighboring device says I'm a trunk, okay, and look, negotiation is on. Everybody, do you see the negotiation of trunking is on? And the default is administrative mode is dynamic auto. And then we're gonna say, yep, if you wanna be a trunk, then I'm fine, I will be a trunk and I will forward the VLAN data for you. And this is how we can prevent VLAN attacks. But by default, it's configured for ease of use. So it's always a balance between ease of use and security. Good, everybody? So this is the balance you're gonna have to find. You want it to be easy to use and secure. And when Cisco made decisions for the switches, they said, we're gonna enable it for ease of use. And we'll let you and I worry about security later on. So just remember those values because basically what these values are saying is the port is enabled, just plug a cable into it. And the port admin mode is dynamic auto, which means it's willing to change its status to a trunk. And trunking is on, which means if a neighboring device says I'm a trunk, this switch will change this port to a trunk and forward data over it. All right. So here we are. Okay. So secure switch. What does the rest of it say? Basic security. Okay. Shut down. Very good. So this first scenario is just basic security. Okay. So I'm saying shut down unused interfaces and disable DTP. And if you guys remember, DTP is dynamic trunking protocol. This is where you can negotiate what the status of that port should be. And if it is dynamic auto, means I'm willing to change my status. Just tell me what would you like me to be. You want me to be a trunk? I will be a trunk. So before we do anything, we want to shut down the ports that aren't being used, and we want to disable negotiation. Disable negotiation disables DTP from doing anything because the port is going to say, I'm not interested. I'm not interested. I'm not talking to you. You can talk to me. I'm not replying back. Does this make sense, everybody? So I'm using interface FA 0, 1, and 2. So I don't want to shut these down, but I'm not using 3 through 24. I'm not using gig 1 and 2. And this is a very smart security move. And the next part is I'm not negotiating. Okay, you can tell me whatever you want. I'm not listening. I'm not complying. So let's do this. And paste it on switch 1. So this is not port security, everybody. This is a step before. And if I was to do show run, and you look under each of these interfaces, and you can see switch port none or no negotiate. I'm not negotiating. Disable DTP. You can't really disable the DTP protocol on the other device. So they can still send you DTP requests, but you can determine if you want to reply to those requests or not. And if I was to look at the show interface FA01 switch, this is the table we looked at before. And you can say I changed the administrative distance to access, which is fine. I have to in order for me to turn negotiation off. So if you're saying, why did you do this? I wouldn't be able to turn negotiation off if it was still auto. And then negotiation is off. And that's really what I wanted to accomplish. I wanted to say I'm not taking orders from my neighbors. The system administrator can tell me if I'm a trunk or not, but I'm not going to change my status because a neighboring switch is asking me to become a trunk. Okay. So now we're talking about port security. This is scenario 2, everybody, and I'm saying shut down. So I'm going to set the limit to 2, a maximum of 2 MAC addresses. And if I exceed 2, I want to shut down. And you can do this, just be careful. Now you know you're shutting down a port. And the people behind that port are not going to be able to do anything until you manually turn the port back on. But depending on your security needs, this may be a smart move. So interface FA01, this is on the switch 1, switch mode access, switch mode port security. So I'm enabling port security, and I'm making the maximum number of 2 MAC addresses. And sticky means, remember those 2 MAC addresses, because if you want to, you can permanently store them into the startup configuration, and then that's it. From that point on, they couldn't use any other 2 MAC addresses. Remember the aging? So if I had used aging instead of sticky, and I said, after 120 minutes, remove it from the table, then 2 hours later, we could use a different MAC address. And then 2 hours after that, we can use a different MAC address because it's being aged out. But sticky means remember it. And remember it gives me the ability to permanently store it. And I am saying that's it. You can only use those 2 MAC addresses. You couldn't use any other 2 MAC addresses until I manually change it. So let's copy and paste. Aging is not enabled on Packet Tracer. I couldn't show it to you, but this is the syntax. And I'm saying age it for 120 minutes. Copy and paste. And again, this is something we've covered before, and I hope it's straightforward. I think port security is straightforward. So show run, and let's look under interface fast Ethernet 01. The mode is access. Port security is enabled. Port security maximum is 2, and I've enabled the sticky option. The sticky is to remember, and I will show you how we can use it in just a couple of minutes. And I didn't do anything else on the other ports. So let's go ahead, and I'm going to show you the CAM table, everybody, on the switch, because we were talking about that a minute ago. Show MAC address table, and it's empty because no data, no end device data has flown through that MAC table. And let me go into emulation mode, simulation mode, and I want to show you ARP, everybody, because we're going to be doing other things with ARP. So if I was to come to PC1, and if I was to try and ping PC5, ping 192.168.1.5. Okay, before I do this, let me show you the ARP table. ARP-8, the ARP cache is empty because PC1 hasn't communicated with any other device yet. So let me ping 192.168.1.5, and let me show you what we're talking about. So yep, it's an ICMP, and PC1 determined that PC5 is in the same subnet. Great, don't need to talk to the router, but now I need the MAC address, and it's sending out an ARP broadcast, and it's going to go to all the devices on the subnet, and only the device with 1.5 IP is going to reply. So if I was to open it up and take a look inside, so we have Ethernet 2, and then we have the ARP, everybody request, and the target IP is this. The target MAC address is all zeros. That's what we're trying to find out. And before I was talking about ARP poisoning, this is where PC3 would reply and say, yep, this is my MAC address. I am 192.168.1.5. This is my MAC address. Talk to me instead of talking to PC4. And that is a problem. And what these bad actors want is they want the data to flow through their device, so they can learn what they need to learn before they can launch an attack. So if I was to continue with this, it's going to go to the hub. The hub is going to do what the hub is going to do. It's going to go to the switch. It's a broadcast. Okay, and only PC4 is going to reply. This is in a healthy environment. Okay, let's go back to real mode. And let me show you the ARP cache now. Okay, and now 192.168.1.5, this is the MAC address for it. Anytime I need to talk to 1.5, I use this MAC address. I don't need to do another ARP because I already have it in the table, in the ARP table, until it is cached out. Okay, until it's deleted from the cache table. And then if I was to go to the switch, and now you can see I have two entries in my MAC address table, one for PC1, one for PC4, because the switch has learned about those two. It still doesn't know about PC2 and PC3 because no data has come from or to them, but it knows about PC1 and PC4. So this is 1. Remember, we set the limit to 2, right, everybody? So this is 1. So let me do another ping from PC2. The same thing will happen. It's going to send out an ARP. ARP -A, empty ping 192.168.1.5. It did an ARP. It found the MAC address. And now if I was to do ARP -A, very good. If I was to come to the switch, very good. Now I know about PC2. Okay, it's sitting behind this port, and this is the MAC address for it. And I've hit my limit, right, everybody? I hit my limit. So let me see what I can see. Show port security interface FA01. Okay, and look, everybody, port security is enabled. You see it, and the violation mode is shut down. And you remember this from here. Okay, and then what else? And maximum MAC address is 2, and the total MAC address is 2. And this is the last MAC address. So I've hit the limit. I've enabled port security. I set the limit to 2. I already have 2. So let's see what would happen if I was to ping from PC3. So who wants to tell me what's going to happen when I try to communicate from PC3 to PC4? Anyone?
Is it not going to be recognized because it doesn't?
Say it a little louder, Robert.
It's not going to be recognized because it's not on the thing because it only has a max of 2.
Very good. It will be recognized, but what is the response going to be? So it's not that it's not going to be recognized. It's going to be recognized. The frame is going to get to switch 1, and what is switch 1 going to do about it? What do you guys think?
Send it back, maybe? Or let it go through the different, all the other ones.
Remember, we enabled port security and we said shut down. So it's going to shut down the interface. So let's do it together. Come over here, and I'm going to ping 192.168.1.5. Remember, we hit our limit, and this would be the 3rd MAC address. We said the limit is 2, and we said we want to shut the interface down. And you see how it one thread, everybody? Except it one thread for everybody. So now PC1 can communicate outside the hub, PC2 can communicate, PC3 can communicate. Okay. And you have to make a decision if shutdown is the right answer or if protect is the right answer. Protect basically means don't allow anymore, but allow the 2 existing computers to continue to communicate. We just won't add any more MAC addresses. I know this is not terribly exciting, but it's important. It's very, very important. And port security is such a foundational security measure, foundational, like you saw in the pyramid. You have to enable it for other things to work. And the same thing is true for DHCP snooping, and we'll talk about that in a few minutes. So let's see what happened with the sticky, everybody. So I'm going to go back here. Let's do show run. Show run. And you see what the sticky did, everybody? The sticky said, remember the last 2 MAC addresses that worked, because we set the limit at 2. And now if I was to do this, if I was to do write, okay, and write is going to save it to startup configuration. And if I was to recycle power, if I was to restart, okay, and now let me look at the running configuration, show run, and you can see I remembered. And now if I was to try and communicate from PC3, let me see what would happen. Ping 192.168.1.5. How about if I spell it right? And it shut it down. Did you guys see that? I just wanted to show you what sticky does. Sticky means remember. I wish they used remember instead of sticky, but they chose the sticky term. And it means you can save those MAC addresses permanently. And next time you turn it on, you have a different third MAC address. It's immediately going to shut down the port. Questions on port security? Do you guys remember this from earlier classes? No? It's all right.
Yeah.
There's just a lot of stuff. I understand. But please remember, this is a security course. And this is a foundational security piece. And you can see how we have disabled all kinds of security violations simply by enabling port security. Simply by enabling port security. Okay, people can do ARP poisoning, people can do the DHCP starvation. You can have someone walk in and plug their computer into a switch and start using it because, you know, we have limits on how many MAC addresses we can have behind these ports. Plus, if you guys remember, the first part of the lab, which had nothing to do with, I'm going to close this. Okay. Was to shut down the ports, the interfaces you're not using. This is another basic security feature. Now, I know it makes the switch less friendly because people can just plug a device in it and use it. You have to enable that port, but it also makes it more secure. And it's that balance I keep talking about over and over again. Okay. And you can see, you know, why this no negotiate is going to help us later on. When a bad actor device says, hey, you know, I'm a switch, can you please turn yourself to a trunk and forward a VLAN data to me? And we want the switch to say no, by default, no. If my system administrator wants me to be a trunk, my system administrator will tell me to be a trunk. Otherwise, I'm not talking to anybody about trunking. Okay, let's do the second part. The second part is scenario 3, everybody, is I just want to go into a protect mode. And if you remember, just a refresher, okay, protect mode is we're not shutting down and we're not logging. Restrict, we're not shutting down, but we're logging. So we're still limiting the maximum number of MAC addresses to 2, but when a third MAC address uses that port, I'm just going to discard and not shut down. So let's redo the lab. And you can see we have a bunch of labs, and we will take our time with them. Scroll down to scenario 3. Okay. Interface FA01, switch mode access, enable port security, switch port security, max 2, violation protect. Okay, so that's the difference. Copy. Show run. If you were to look under interface FA01, maximum 2, violation protect, show MAC address, empty, and the ARP caches are empty. So let's test it again. And we don't have sticky enabled. Everybody, we don't have sticky enabled. So ping 192.168.1.5. I'm gonna do the ARP thing. The switch is gonna learn about those two computers and add them to the MAC address table. Show ARP. So this is the ARP cache, and it worked. And then come to PC2. And in fact, I want to come to PC3, being the second device, and it's going to work. I set it to 2, and if I was to come over here to the switch, show port security interface FA0, hold on, show interface FA01 switch. Okay. That's not what I want to see. Show port security FA01 interface. And you can see the maximum address is 2. The current tally is 2. And the violation mode is protect. And now if I was to try and communicate from PC2, it's going to fail. And it's discarding it. I could simulate, but switch 1, FA01 is discarding all those PDUs that are coming from PC2 with a third MAC address. Questions? About port security. All right, let's move on. So this is mostly a review. And I know you will remember this pyramid, everybody. You will remember this pyramid, and you can see port security is like a foundational security feature that enables some of the higher level security as well. So let's do a few more slides and move on. Okay. Mitigating VLAN attacks. Okay. So we have a bad actor over here. They have a device and they connected to this switch and they said, I'm a trunk. This is the conversation I was having before. And if we leave the switch configurations at default, then that port is going to say, fine, I will change myself to a trunk and I will forward the VLAN data to you. Do you see how that is a problem, everybody? Okay, so we want to prevent that from happening, and I already showed you how to prevent it from happening. Just say, I'm not going to negotiate. If my system administrator wants me to be a trunk, they will tell me to be a trunk. But I'm not going to change my mode from access to trunk because a neighbor is requesting me to change from access to trunk. And by default, the switch would change its mode from access to trunk because it is configured by default for ease of use. And when you take a switch out of the box, you want to immediately enable security. How much security, it depends, but you want to make it more secure. You want to have a more secure switch. So this is what we're talking about here. Let me see what else is on. Double tagging is basically where you can tag a PDU with 2 tags. So it will go through one VLAN, and then from there it will go into another VLAN. So let's say, you know, your neighboring device only speaks VLAN 10. Well, you can double tag it. The first tag is for VLAN 10, the next tag is for VLAN 20, and then it will forward it to the other VLAN. This is what double VLAN tagging is. Gives the bad actor the capability of going through 2 VLANs before they get to the VLANs they really want to get to. Mitigating, you know, the easiest way to mitigate is just to turn the negotiation off. And then I will talk about PVLAN. So let's do a lab, everybody. I'm going to skip the DHCP helper, come back to it later on. So we're going to do 5. And 5 is to prevent a VLAN attack. So you can see in Packet Tracer, I have 2 legitimate switches, okay, and I have a bad actor switch. And in order for the data to flow from switch 2 to the bad actor to the rogue switch, you know, we need to convince switch 2 to change its gig 01 port to a trunk. And then it's going to say, yep, I'm a trunk. I'm going to go ahead and forward the traffic to this rogue switch. And by default, that's an easy thing to do. We've covered that already. Okay. By default, switch interfaces are configured. Let me see the whole thing as dynamic auto anti-negotiate, right? Everybody, I showed you that. That's the default. Okay, it's dynamic auto negotiate. And then you do what your neighbor tells you to do. Admin mode, dynamic auto negotiation on. I will show you one more time. Okay. And this is on switch 1. Switch 1. EN show interface gig 02 switch. Okay. Administrative mode by default auto, and negotiation by default on, and enabled mean it's up. Anyone can plug a cable into this port and it's going to work. So these are the default values. And we've covered this in a previous class, everybody. So if you have 2 switches, 2 devices, and one device has the port configured as dynamic auto, which is the default, and the other end of the cable configures itself as a trunk, and the first device will change its configuration to a trunk. So this is if you leave it as dynamic auto, and if you leave it as negotiate. Versus if you were to change it to access, which is what we want to do, and your neighbor says, I'm a trunk, then it's limited connectivity. And limited connectivity is far better than saying, yep, I'm a trunk. Okay. So let's do the lab. Okay. So at first I want to configure VLAN 10 and 20 because by default we only have VLAN 1. So VLAN brief, it's just VLAN 1. And we have the yellow and the blue subnets, VLAN 10 and 20. So I'm going to configure them, I'm going to name them, and I'm going to assign them ports. And the naming is optional, but it's useful. So conft, and then do the same thing on switch 2. And if I was to look at the current VLANs, so VLAN brief, and you can see I have 1, 10, and 20, which is great. I have the same. Okay. And right now, everybody, let me ask you a question. But first, let me show you. So interface trunk. Okay. I don't have a trunk interface. Can PC1 communicate with PC3 right now? Does anyone know? Let me show you one more thing. Show VLAN brief. So gig 01 and 02 are belong to VLAN 1. Okay. So this interface is not on VLAN 10 or VLAN 20, and the answer is no. The answer is PC1 cannot communicate with PC3. It's going to go to the switch, and the switch is going to say, I can't find PC3 on this switch. And it doesn't have a trunk, so it can't forward the VLAN data. And there are two ways of trunking. We can enable trunking on both ends of this interface, which is the smart thing to do, or we can leave the switch configurations as is and enable trunking on one end, and then DTP will do the rest for us. So let's do that. Okay. So on switch 1, I'm going to make gig 02, everybody a trunk. And then DTP will do the rest for me. And if you want, we can simulate it and see that. And that's because I already showed you right here. This is on switch 2. Okay, the administrative mode is dynamic auto, negotiation is on, and dynamic auto trunk, change it to a trunk. So let me do this in switch 1. It doesn't really matter which switch you do it on. Fast forward and show interface trunk. Everybody, I only did this on switch 1, but let's see what happened to switch 2. In fact, you can see right here. Okay, so you can see the negotiation happened, and they changed the interface to trunk and show interface trunk. And here we are. And this is what we want to avoid. We want to avoid the rogue switch doing the same thing for the port it's using to connect to switch 2. Because we don't want switch 2 to say, no problem, I will change to trunk and I will forward all the information to you. So now PC1, 2, 3, and 4 can communicate. And now LT1, 2, 3, and 4 can communicate. And very quickly, ping 192.168.1.4, and it's working just fine. Okay. However, if I was to come to this rogue switch and type show interface trunk, I don't have a trunk yet, which means switch 2 is not going to forward the VLAN data to me yet. And that's what we want to do next. So next scenario, on the rogue switch, let's tell it that interface gig 01 is a trunk, and now DTP is going to negotiate with switch 2. And because we haven't changed the switch 2 default configurations, it's going to change the trunk. Copy. Paste, fast forward, and you can see before it was orange, and then it said, yep, fine, I'm good. And if I was to come here, yep, now we're forwarding VLAN 1 through 1005, and from switch 2 point of view, show interface trunk, and it said, yep, gig 01 is a trunk, and get to this rogue switch, and gig 02 is a trunk to switch 1. Make sense, everybody? And now this bad PC can communicate with yellow. Ping 192.168.1.2. And that is a problem because we don't want the bad actor devices to be on the network, and we just put them on the network. So how do we fix this? How do we mitigate this kind of a security attack? Anybody?
Disable auto negotiation.
Say it again, Joey.
Disable auto negotiation.
Thank you very much. Disable auto negotiation. Everybody, which is what we did before. Just tell switch 2, you know, on all the ports except gig 02, you know, you are not to turn them to a trunk unless I, the administrator, tells you to turn them to a trunk. And we can stop the rogue switch from sending DTP messages, but we can ignore them. And that's what we want switch 2 to do. We can ignore them. In fact, we want them to do the same thing between switch 1 and switch 2 because we don't know who's a rogue device and who is a legitimate device. And only the system administrators have access to the switch and can configure the switch interface to be a trunk or not. And that is like basic stuff to do. So let's redo it. Let me see. So let's come back. Okay. Okay, very good. Well, I have to do this part first. I have to configure the VLANs. So I will do this quickly. Conf T. Conf T. And then scenario 3 says to address the security issues, change switch 1 and switch 2 interfaces, admin mode to access mode. Okay. And non-negotiate. Okay. So let's go ahead and do it. Okay. And you can see over here, I'm saying interface range FA01 through 24. Okay, their access mode and non-negotiate. And then gig 1 and 2, same thing. So I'm going to copy and paste. And let me paste it on 1 and 2. Just paste it and paste it. And now if I was to do show run, and you can see it says switch port access, no negotiate, access, no negotiate on all of them, which is what you want. And now if you want gig 02 on switch 1 and switch 2 to be trunks, you have to configure it on switch 1 and switch 2. And let me show you. So let's say I go ahead and configure it on switch 1. Fast forward. You can see on switch 1 it's green, on switch 2 it's orange because it's saying I'm not going to change to a trunk. And I can do show interface trunk. Okay, however, the same isn't happening on switch 2. And it's telling us inconsistent port type. This is the error message. Switch 2 is generating in response to the DTP request from switch 1. Saying, nope, I'm not going to do it. And do show interface trunk. And nothing's going to happen until I manually tell switch 2 gig 02 is a trunk. And now both of them have enabled gig 02 as a trunk. And now they are forwarding VLAN data across switch 1 and switch 2. And now to go back to the rogue switch, if the rogue switch was to change gig 01 to a trunk, switch 2 is not going to respond. And I think that's the rest of this lab. Okay. So let me change this to 1 and come back here. And now I'm going to change gig 01 on the rogue switch to be a trunk. Fast forward, and you can see this is green saying, yep, I'm a trunk on the rogue switch, and switch 2 saying, okay, I'm not changing my status to trunk until my system administrator tells me to do so, which is wise and smart and basic and something you want to do. Any questions about this lab? So what I'm hoping I'm doing is to show you the vulnerability and show you how we can mitigate it. This is the vulnerability. This is how we can mitigate. This is the vulnerability. This is how we can mitigate. Questions? Boring stuff? Useful stuff? Interesting stuff? What do you think? I think, me personally, as an instructor, Chapter 6 is one of the better chapters in CS285. It actually talks about stuff we can do to secure our network, starting with layer 2. Nope. Undecided?
I think it's all really useful stuff.
Okay. Thank you, Joe. I really believe so too, and I hope you think so as well. And your job as a network administrator is to harden your devices, harden your network, harden your server, and harden means, you know, make them more secure. And these are fairly easy steps to do that will harden your network, your devices, your servers. Okay, I'm going to move on. Let's go back to the slides. And I will do 2 more labs and stop. And I'm sure I will get to the rest of them by the end of Thursday. And I want to give you time to digest, because if you understand the stuff down below, it's easier to understand the stuff higher up, because it's a pyramid of knowledge. And if you have a solid understanding of the first 2 layers, which is all I hope to cover today, then it's going to get easier as we work our way up. And the same is true for your studying. You know, if you get your brains and your arms around CIS 151, 152, 153 will be easy. Otherwise, you know, it's going to be a miserable experience after that. The same thing is true here within chapter 6. So let's go back to the slides. PVLAN. Do you guys remember this? We did cover this before. So we have a VLAN, let's say VLAN 10. However, we don't want the devices on VLAN 10 to be able to communicate with one another. We don't want unicast, we don't want broadcast, we don't want multicast between these devices in the same VLAN 10. And I know what you're thinking. You're saying, why put them in the same VLAN to begin with if you don't want them to be able to communicate? And the best scenario I can give you is a hotel. So you checked into a hotel, you know, you checked into room 202, and there is a bad actor in room 201. And it's like, fine, we're in the same VLAN, because you don't expect the hotel to create a VLAN for each room. Okay, that's just, you know, impractical. So maybe the entire second floor is one VLAN, but we want to use this edge feature where the devices inside that same VLAN can communicate with one another. Because I want to be able to go to the outside from my room. I want to be able to connect to the internet. I want to be able to do whatever I want to do. But I don't want my neighbor intentionally or unintentionally to see any of my traffic, nor do I care to see any of their traffic. So does this explain why sometimes you may want to use a private VLAN? This is what the P stands for, a private VLAN, edge feature. And if you were to look at this diagram, you know, we have 2 PCs. And if it was me, I would say room 202 and room 201. Okay, and of course they can go to the outside and the outside can come into their room, but we don't want them to be able to communicate with one another. Nothing, no unicast, no broadcast, no multicast. So let's do the lab. This is all it is. Okay, and then we move to DHCP. So let's do this in DHCP and stop. So PVLAN, lab 6. Okay. So use private VLAN when end user devices shouldn't communicate with one another, unicast, broadcast, and multicast traffic. Of course, end user device should be able to communicate with the DHCP, email, web, etc., and the internet. Of course, if you're in a hotel room, you want to get an IP from your DHCP server and then be able to go out into the internet. And best example are hotel rooms on the same VLAN. Don't want room 201 and room 202 traffic and vice versa. So how do we enable this? We just enable the protect. Please don't confuse this protect with port security protect. So we're using the same term, protect, except this is a PVLAN protect versus port security protect. So same term used differently for different purposes. Okay, and that's it. Okay, so basically I'm saying FA23, notice I don't have one, protect on all of them. So interface range, that's it. It's very simple, but let me show you the picture and you tell me why didn't we include FA01? Okay, so why didn't we include interface FA01 to this range? Anybody?
Because FA01 is connecting to the outside.
No, it's not the outside.
But the internet, the DHCP.
It's very good. You put your finger on it, okay, but it's not the outside. It's the DHCP server. We most certainly want PC1 and PC2 to be able to communicate with the DHCP server, right? Everybody, otherwise, how would they get an IP? So if I was to put FA01 in protect mode, and now PC1 and PC2 cannot talk to the DHCP server, and they wouldn't be able to get IP addresses. So what's cool about this is it gives you the flexibility to decide which ports you want to set in protect mode. And any device that you want the other devices to be able to talk to, then don't specify it as a protect port. Otherwise, they wouldn't be able to talk to it. So what we're saying here is PC1 and PC2 should be able to communicate with DHCP. However, they shouldn't be able to communicate with one another. They shouldn't be able to see each other data. And you can think of this as room 201 and this is as room 202. So let me do it on switch 1. And now I go to PC1, I go to desktop, and it doesn't have a static IP. I'm going to enable the DHCP. In fact, I want to simulate just to show you. Okay, and go, and you can see it made the data made it to the DHCP DNS. It did the ARP thing. Okay, and I'm going to go back to real mode. Okay, sorry everybody. I clicked on the wrong thing. So redo it. Okay, let's just fast forward. PC1, DHCP, and it should get to 192. Everybody? So it was able to communicate with DHCP, and the same thing is true for PC2, should be able to communicate with DHCP, and should be able to communicate with the outside world. The outside world being PC3, etc. And PC3 needs an IP, so let's give it an IP. And this is 210. And PC1 should be able to communicate with 210. Good, everybody. And let's see if PC1 can communicate with PC2, but I want to go into simulation mode and see. And 2 is with IP. 2 is 14. So I'm gonna come over here and ping 1.4, and let's see what's gonna happen. We're gonna do ARP. So PC1 decided that PC2 is in the same subnet, and I need its MAC address. So it's gonna come over here. Do you see, did the broadcast go to PC2, everybody? So you saw that, you know, the switch said, okay, this is a broadcast, but I'm not gonna send it to the PV LAN nodes. And if it didn't get to PC2, PC2 is not gonna reply, and that's the end of that, right, everybody? There's no ways they're gonna be able to communicate. So you can see even a broadcast didn't get from PC1 to PC2 because this is what we wanted to prevent. And go back to real time, and it's gonna fail. So it's fairly simple. It has limited use. And I think I gave you the best scenario. Okay, is a hotel room. A hotel may want to use this feature to protect their clients from one another. Questions on PVLAN? All right, we move on. So before I talk about DHCP, I want to talk about DHCP helper. So let's do this lab together. And this is a review, everybody. We've been using DHCP helper for a long time, but it would be good to review DHCP very quickly. So we're talking IPv4 here. We're talking stateful DHCP server that provides all the information, IP, subnet mask, default gateway, DNS, domain name, any contract, and we renew the lease 50% into the contract. And the D in DORA, I'm sure you remember DORA, discovery, offer, request, acknowledge, DORA, that's the DHCP process for IPv4. The D is a broadcast, and it works great for the devices that are in the same subnet as the DHCP server. However, what if that DHCP server is providing DHCP services for other subnets? Well, that D broadcast isn't going to get to the DHCP server, and this is why we have this IP helper. And the IP helper, you enable it on the router interface and say, when you receive a discovery request, please forward it to this DHCP server, and then when the reply comes back, I will send it back to the device that requested the service. So it's just an agent that sits on the router that forwards the request back and forth. Okay. So if I was to go to the DHCP server, go to services, go to DHCP, you can see I have it configured for all the local area networks that have devices. So this is the one and only DHCP server for this subnet, this subnet, this subnet, and this subnet. So let me come over here and give PC1, okay, an IP address, and that's gonna go well. Let's simulate, because it's in the same subnet. Let me go back into real mode, static, and now I'm going to requesting a DHCP, and DHCP, everybody, and it's a broadcast, and it's going to get to the DHCP server. We're doing an ARP now. Here we go, and it's going to send an offer. The DHCP server is going to say, yep, I can help you. Okay, I can give you this IP, this subnet mask. And then the PC1 is going to say, yep, it sounds great, I request it. And then the DHCP would acknowledge, and we're done. And now we go back, and PC1 has a valid IP. The problem is if PC3 does the same thing, and we haven't enabled the IP helper on router 1, it's going to send a broadcast, and the broadcast is never going to make it to the DHCP server. And I want to show you. And this is why we need that helper. 169 tells you a lot, everybody. So I want DHCP, and fast forward, it's a broadcast. It's going to go to the router, and the router is going to say, that is the end of this broadcast. and nothing's going to happen. And it's going to end up assigning itself an APIPA IP. And I know you all remember about APIPA IP 169, which means A, I couldn't find a DHCP, or B, I found a DHCP and gave me bad IP, an IP that's already being used. And those are the two common causes of 169. I couldn't find DHCP or it gave me bad information. So I want to enable IP helper to resolve this issue. And you can see over here, interface gig01. This is the interface for the second subnet, and I'm enabling the IP helper, and it's going to forward the requests. And I hope this is a review, because we've done this quite a few times before, but reviews are good. And do show run, and look under interface 01, and you can see IP helper address. And now what's going to happen is when PC3 sends out a broadcast, the router is going to forward it. So it's going to go to the router will send it to the DHCP server, the DHCP server will reply, the router will forward it to PC3, and that way PC3 can get a legitimate IP. And we can do the same on router 2, and now it's going to work for all 4 subnets. So you don't have to have a DHCP server on each subnet, because if you have 250 subnets, you don't really want 250 DHCP servers. And this is how you work around that. And then we do the same thing on router 2. And now it's going to work. Over here, it's happy, and over here. And I know you remember APIPA 169. And I'm telling you the 2 most common scenarios that result in an APIPA IP. I'm configured for DHCP, but DHCP isn't reply, which was the case before. Or I found the DHCP and gave me an IP that is already being used, and I had to drop it because it's already being used. And I assigned myself an APIPA IP. Any question on IP helper? All right, let's talk about how can we mitigate DHCP attacks. So I talked about 2 different kinds of DHCP attacks. I talked about the starvation attack. Everybody, you want to starve it, you have a legitimate, you go to Starbucks. Starbucks has a legitimate DHCP server, you want to starve it from the legitimate IPs it has, and that doesn't take very long because we're talking usually about a class C, that's 254 IPs maximum. So that's the second, and we've starved it. And we do this by requesting an IP with a different MAC address, So we're spoofing the MAC address and we're requesting different IPs. You do this 300 times, you've starved it. It has no valid IPs left to give. So how can we mitigate against that? From what you've learned today, how can we mitigate against a DHCP starvation attack? Two words. Port. What's the other one? Security. Do you guys remember port security? So if I was to limit the maximum number of MAC addresses behind a port to 3, then worst case scenarios, they will use up 3 legitimate DHCP IPs and not nearly enough to starve it. Okay, so this is why when we're talking about port security, I said it enables other security features, and port security will be able to prevent all kind of attacks where we are spoofing the source MAC address. anytime we change the source MAC address, we can put a limit on that. And that is true for ARP poisoning, we'll talk about later, and it's definitely true for DHCP starvation. So how do we accomplish DHCP security? And it's really simple, everybody. So this is the DORA process we talked about. We talked about DHCP starvation attacks. There's lots of programs out in the internet that will do this for you. Please don't use it. Be kind, be nice. But it's very easy to do. And the DHCP server has no valid IPs left. Now it has to wait until one of those leases expire and the person is no longer using the IP before it can assign a valid IP. And the second stage is to pretend, the bad actor is going to pretend that their device is the DHCP server, and now they are going to give their device IP as the default gateway IP. Basically, what they're trying to do is they're trying to force all the traffic through their device. And if you tell all these computers, I am your default gateway, go through me, now you're forcing all the traffic to go through the bad actor device. And this is it for DHCP attacks. Starve, step number one, and take over. I am the new DHCP server. Okay, and the best security against protecting your data is encryption. Encrypt everything. That way they can still get their hands on the zeros and the ones. They can get their hands on the header data because you can't encrypt the header data, but at least your data is secure because it is encrypted. And this is why security is becoming the norm in corporate planet Earth. Yep. So we will talk about DHCP snooping, and snooping, basically the term means we're snooping on DORA. This is what snooping is. I'm snooping on the DORA process because I want to capture the MAC address and the IP that goes with it. And I'm going to create what's called a binding table. And this binding table is a table that has legitimate MAC, legitimate IP, legitimate MAC, legitimate IP, legitimate MAC, legitimate IP. And anytime we get a request where the MAC and the IP don't match with what we have in the binding table, Houston, we have a problem. Make sense, everybody? So this DHCP snooping becomes a foundation for other spoofing services. This is how we protect against MAC spoofing. This is how we protect against IP spoofing. We have to create this table first, this binding table, and then we check against it. And if they're giving us an IP for the wrong MAC or a MAC for the wrong IP, we know, and we can respond. So this is DHCP protection, everybody. It's really, really easy. You determine as a network administrator which port is a trusted port and which port isn't a trusted port. And basically, the one port that connects you to the DHCP server right here, this is a trusted port. And then the ports that connect the switches to each other are trusted ports. And the ports that connect to end user devices are untrusted ports. Meaning if you were to receive a DHCP request, not from this port, but to this port, you ignore it because there is no DHCP server behind that port. I'm not going to allow a discovery to go through that port. Discovery from DORA. Make sense, everybody? So it's really easy. And this will protect you against DHCP snooping and DHCP starvation. It will protect you against DHCP starvation because this is the bad actor right here, everybody. And the system administrator, you have determined that this port is untrusted port. And you're not going to allow them to starve, nor are you allow them to act as a DHCP server. We mitigate the starvation by using port security, and we mitigate the rogue DHCP by saying this is an untrusted DHCP port. So let me stop here and ask if that makes sense. That two-part process, DHCP starvation and then taking over DHCP service.
Windows.
Okay, very good. And I want you to know it's not always a malicious act to provide a DHCP service. I mean, sometimes it's malicious, but sometimes it's just innocent, but still it wreaks havoc when you do it. And I will give you a real life example, and then we'll do one more lab and call it a day. So back when I was still working at HP and I was in 5 Upper, and 5 Upper is this large floor with, I don't know, 300 people in it. And I'm sure it had multiple local area networks. But for a few days, people were bringing in their laptops in the morning and they were getting a 169 IP. Some people were getting 169. And we know 169 is a PIPA. And it never happened to me because I never brought my laptop home with me. It was just docked all the time. I left it in the office. I had a legitimate IP. I went back to my DHCP 50% into my lease. I renewed my IP. So it was working fine for me. But some of the individuals that were taking their laptops home with them and bringing them back in the morning and requesting a DHCP were getting an APIPA IP. And after hours of frustration, they came over to me and they explained the problem to me. And I said, it's easy to troubleshoot. Let me just run Wireshark and let me request a new IP. And I sent out a D, everybody, and 2 O's came back. 2 offers came back. And I said, well, this is interesting. We only have one legitimate. Who's this other DHCP server that is offering IPs from the same range? There's nothing wrong with having 2 DHCP servers on the same subnet, but you have to break the range in half. You can only give IPs from this range and you can only give IPs from this range, because if they were giving IPs from the same range, you're going to have conflict. You're going to end up with 169. So I said, okay, we have a rogue DHCP server. So we called IT and we said, if I give you an IP or if I give you a MAC, can you give me an office number? And this is the beauty of proper documentation, everybody. And they said, easy. So they tracked it to a switch port. And then that switch port had a cable that went to a cube. And all of this is documented. So the 3 of us walked over to the cube and there was a guy sitting, typing away on their laptop. And we told them who we are and what we're interested in. He said, nope, I don't have a DHCP server running on my computer. And I noticed he had a desktop. I said, what are you running on this desktop? He told me Windows Server. I said, do you mind if I log on? He said, no big deal, you can. And lo and behold, he enabled DHCP unintentionally. So it's not always intentional. You can enable DHCP service on your smartphone, everybody. So it's just a service, and it's a very, very simple service. And people can innocently enable it, and then it will result in serious problems. Because if that was the DHCP server that replied to the user first, and they gave them a bad IP, meaning an IP that's being used, they're going to end up with an APIPA. If HP at the time was using, trusted ports, which is what we're talking about here, they would have, prevented that problem from happening. They would have said only this one port can reply to the DHCP requests, and all the other ports are untrusted. And people could enable the service, but it wouldn't do any harm. And that's what we want to do. So let's do the lab. So this is lab 7. Wow, we made it to 7. Good, quick. And it's fairly straightforward, everybody. In fact, all of them are straightforward, as the important part is to understand. The implementation is straightforward. You just have to understand. And once you understand, the rest of it is easy. So let's see what this says. The DHCP snooping features determines whether traffic sources are trusted or untrusted. An untrusted source may initiate traffic attacks or other hostile actions. To prevent such attacks, the DHCP snooping feature filters messages and rate limit traffic from untrusted sources. Not trusted port, don't allow the discovery PDU in the DORA to pass. snooping in the DORA process and capture the IP to MAC address table, this binding table, everybody, I want you to make a note of this. Okay, this is a feature that enables higher level security features we'll talk about on Thursday. So we do need the binding table dynamically or statically. The DHCP snooping binding table is used with dynamic ARP inspection and IP security guard. The two top players on the pyramid need that table to do their job. And I gave you a lovely URL, and I hope you will click on it and spend a few minutes and read about it. Okay, so let's do the lab. Scenario 1, DHCP is working well. So we have a rogue DHCP, except it's not enabled right now. DHCP, it's off. And we have a legitimate DHCP, and life is good. So give it DHCP IP, DHCP. So it's working as it should. Everything is functioning like IT would like it to. Okay, 192, very good. And they came from this DHCP server. And of course, on R1, I have IP helper for the subnet. So those requests would come to the one and only DHCP server. Okay, a scenario, disable DHCP on switch 1. Okay, assume we don't want to use DHCP. Okay, very good. So this is the snooping service, everybody. So when you type IP DHCP snooping, you're saying, I don't trust anybody. So immediately, including your legitimate DHCP port. But you're starting with a blanket, I don't trust anybody, and now tell me who to trust. Okay. And then we're doing it for VLAN 10. Okay. And let's see what happens when I do this. And it's not gonna work anymore because I already said I don't trust any ports. And if you don't have any DHCP servers, then you're fine, except make sure you trust your trunk because you want those requests to go over the trunk. Paste, do show run, and you can see it right here, everybody. IP DHCP snooping, and for VLAN 1, okay, very good, and that's the only VLAN I have. I don't have VLAN 10 and 20. And now if I was to go to PC1, take the IP away, request a new IP, and it's going to end up with 169 because we said we don't trust any port. Good. And we can simulate, and you can see, you know, the switch wouldn't forward the D request to the DHCP because I already told the switch all ports are untrusted. So number 2 is, let me do this. Show IP DHCP snoop. This is the table, okay, and binding, this is the binding table, and they're empty, but they will have stuff in them later on. Okay, so let me see what does this say. Okay, enable the DHCP snooping, very good. So I want to trust everybody. So I'm just going to add this interface FA01. FA01 is where the DHCP server is, and trust. Okay, and don't trust the other ones, and limit the rate to 6 requests per second. And this is to try and slow down the starvation attack. So let me do this. And just paste it. And I really, truly hope you're going to do all these labs before Thursday and take your time with them and do show run. Okay. And you can see under fast Ethernet 01, IP DHCP snooping trust. And then for the other ones, I'm setting the rate to 6 requests per second to slow the starvation down. And then let me see if it's working on PC1 and PC2. And it's 192, it's legitimate. and it's 192, it's legitimate. Everybody. And now if I was to enable this bad actor DHCP, it's not going to work. It's not going to work because this is an untrusted port, everybody. And this is what we're going to see next. And let me show you the snooping table. Show IP DHCP snooping. Okay. And this is trusted. The other ports are not trusted. And you can see the rate limit per second. And the binding table. And this is the binding table. Remember, we requested DHCP from PC1 and PC2. This is PC1 MAC, and this is PC1 IP. This is PC2 MAC, and this is PC2 IP. Okay, and we have lease, etc. And this is an extremely valuable table, everybody. And we will use this table to protect ourselves against MAC spoofing, because if an IP was to change the MAC, we can look against this table, say, Houston, we have a problem. And we can also use it to protect against IP spoofing if someone was to change their IP. And then we're going to look at this table and say, this IP doesn't belong to that MAC. Make sense, everyone? So this is a super useful table. This is the rest of chapter 6. Okay. So let's see what happens when we enable a rogue DHCP server. Okay, so I'm gonna come over here. I'm gonna disable the DHCP service intentionally off, and I'm gonna enable the bad actor on. Okay, so let's pretend we starved the DHCP server from legitimate IPs. And now we are claiming ourselves to be the new legitimate, and we're going to be assigning bad default gateway IP, and come back to PC1 and DHCP, and it should end up with 169. And it's 169 because that port behind which the bad DHCP server is connected to is untrusted port. Very easy to implement. I don't think I've talked about anything so far that is hard to implement. Everybody, there is nothing we've covered today that is hard to implement. The problem is people don't do it. People don't do it. And then you end up with problems, sometimes intentionally, sometimes unintentionally. You end up with problems. And we can mitigate, we can avoid. All we have to do is use those security features that were designed for that purpose and are easy to implement. And what is most important to me, as always the case, is that you understand, not that you memorize the syntax. I don't care. You can always Google it. You can always look it up in a file. But I want you to understand, this is the problem. This is how we mitigate it. This is the problem. This is how we mitigate it. This is the problem. This is how we mitigate it. And I hope this is what we accomplished today. Questions? We're good? Making sense? Connecting the dots?
Yep.
Okay. So I would encourage you to do these labs before Thursday. And we will do a quick review on Thursday, and then we will do a few more labs and finish the slides. But chapter 6 is, in my opinion, very, very important. And those security features we talked about today are easy to understand, easy to implement. And my experience working for a large, high-tech, bleeding edge company is they didn't implement it. And if they had, they would have saved us some headache. And I hope you will. So you have a great day, everybody, and I will see you on Thursday to finish chapter 6.
Good.